Alright, thank you so much for joining in. Okay, so we continue solving our inequalities. So here we want to find the inequalities defining the unshaded region. Remember, we are defining the unshaded region. Okay, so the first inequality, so let's look at this equation, this graph here. Okay, this one. Okay, right. So since we want the unshaded region, if we find the shaded region, then we write the opposite of what we have found, isn't it? Okay, so we can look at the first one here. So this line, observe that it is passing at x is equal to 2, right? It is shaded to the right side, which means the values on the right side, it includes all the values which are greater than 2, isn't it? And the line is not breaking. So since the line is not breaking, it means our inequality will be x, right, is greater than, right, is greater than 2. Now greater than or equal to 2, because 2 is included. So this is the shaded region. So the unshaded region, so let's say we have the shaded region here. So this inequality is describing the shaded region. Now the unshaded region here, okay, is being described by the equations here. I'm going to write them there so that it will help you. So since this is describing the shaded region, then the unshaded region will be described by x is less than or equal to 2. It will be the opposite of what we have. So the second one here, we're going to look at this one. We can look at this one here. Okay, now this line here in green, notice that it is breaking and it is shaded downward, right? Okay, so since this line is breaking, then we can observe that upward here, all the values upward here, they are greater than the downward. So the shaded region downward here, okay, the shaded region downward is y, right? So as you go in the y-axis, why have I used y and not x? In the y-axis, when you go down, as you go down, you are approaching all the values which are less than the top part, right? That is the x values, that is the top part, isn't it? So that's the ones you are approaching, and this is the area which has been shaded. So in the y-axis, all the values you are approaching, they are less than the top part, which is the values of a negative x. Okay, what does that mean? It means for any value of y that you pick will be less than a negative value of x. Okay, let's say we get negative 1 comma negative 1. If we try to fix in negative 1 comma negative 1 here, right, we fix in this equation, we're going to in inequality, we're going to have y negative 1 is less than negative open bracket negative 1, and we're going to have negative 1 is less than positive 1. Is this true? Yes, this is very much true. So it means for any value of y that we pick, it will be less than the negative of any value of x that we pick. Okay, so we had picked the value of x to be negative 1, so the negative of that gave us positive 1, which is greater than the value of y that we picked, which was negative 1. So this is describing, this inequality here is describing the shaded region, which is the outer part. Okay, now that we are looking for inequalities describing the unshaded region, we are getting the opposite of what we have. So we are getting y will be greater than or equal to negative x, right? And that is very much true. Let's say we pick on any two values on top. Let's say 1 comma 1, which is they are meeting in this region inside, that is the unshaded. If we pick positive 1 comma 1, so let me say we pick positive 1 comma 1, we want to test if these are in agreement. We are going to have, if we fix where there is y, we substitute with positive 1, we are going to have 1 is greater than negative of value of x, which is 1. Is this statement true? Yes, it is very much true. A positive 1 is always greater than a negative value, okay? And in this case, positive 1 is greater than negative 1. So this describes the upward part, which is the unshaded, one of the unshaded, the inequalities describing the unshaded region, okay, which is the inner part of R. Okay, so this is the second equation. Now the third equation, or we can look at this one here, okay? This line here, I can use a different one. Okay, yeah, let me use a yellow one. So this line, you can look at it. So the line is passing in the y-axis at 6, and it is breaking. Okay, this line is breaking. So since it is breaking, the inequality will be the inequality describing this region, that is the top part, it will be y, right, is greater than 6, isn't it? Okay, and these equations, because they are not breaking, they should have or equal to there and equal to there. Sorry, I forgot that. Okay, all right, I've written on top there. It's just this one that I forgot, so it should have greater than or equal to negative x. Also this one here for the shaded region. Okay, so that's it. So this equation now we're looking at in yellow. So the equation, we have identified that this inequality, the graph is described by y is greater than 6, because all the values here on top, they are greater than 6 in the y-axis as we go upward, right? Now we are describing the unshaded region, which is inside, which is the opposite of the inequality that we have. So the inequality describing that unshaded region is y greater than, less than, is the opposite of what is being described by the shaded region. So it will be y is less than 6 and not greater than. So this is our third inequality, right? This was our second inequality, and this was our first inequality. Okay, this was our first. So we can write the third one now, which we can solve. So the third inequality, we can use the formula for we can identify the coordinates first. We can get the points. So this line is passing in the x-axis at -2, okay, comma 0, right? Hope you have seen this line. This line is the one passing here, okay, this one. So in the x-axis, it is touching the x-axis at -2, right, which gives us the coordinate -2, comma 0, and in the y-axis it is passing at 0, comma 4, right, 0, comma 4. So we can solve this one. So we can start by calculating for the gradient, which we know the formula for the gradient is y2 minus y1, right, divided by x2 minus x1, and this is going to be our y2, right? Our y2 is from here we can get this one to be our x1 and our y1, so that the remaining, this pair can be y2, x2 and y2. So our y2 in this case will be 4 minus 0, right? And our x2 will be 0 minus, open bracket, negative 2 is our y1, right? So solving this will give us 2 as the value for the gradient. Now we can apply the standard equation for linear equations, okay, so that we can calculate the value of the constant, which is c. So the equation is y is equal to mx plus c, which is here, right? So applying this one, we have we can choose any pair. We can choose this pair 0, 4, where we have the x value and the y value. You can pick on any pair, okay? So the y value that we have is 4, which will be equal to our gradient value. It was 2, so our y value in this case is 0 plus c, okay? So this is giving us the value of c to be 2, right? So writing our final equation, inequality, will be writing again y is equal to mx, right? That is gradient multiplied by the x value plus the constant value. So replacing only with m, that is 2, which is our gradient, and x, that is plus c, which is 2, we get that equation describing the shaded the line, right? That is the line. Now we are looking for the inequality describing this line. Okay, looking at the shaded part, the shaded part is on top, isn't it? So the shaded part is the greater part, because the inequality has been shaded upward, okay? So since the shaded part is on the upward, that means our inequality there can just be that y is equal to 2x, y is greater than 2x plus 4, right? That is what is describing the shaded part, which is the upward part, this part there, okay, which is the not part of region R. So if you want to get the region R, we write the opposite of what we have written. So sorry, here let me just write what is supposed to be there. So we are saying the shaded part is being described by the inequality, which is going to have y is greater than, right? Y is greater than 2x plus 4. Now the region describing, the inequality describing the unshaded region will be the opposite of what we have, which will be less than 2x plus 2. Is it 2 or 4? Sorry, so this value here, it's supposed to be 4 and not 2. So here we need to have 4, okay, and here it should be 4, because the value of c is 4 here, okay? It's giving us 4 and not 2. All right, so these are the 4 inequalities which are describing our unshaded region, that is region R. Hope you're able to see it. That is this one here, okay, this one here. This is our third inequality, and the first one here, or the second one describing the unshaded region, okay, and this one here, okay, that is this one here. So we have all the four inequalities written here. So we have the first one here, the second one, third one there, okay, and the fourth one here. So those are the four inequalities. All right, thank you so much. Let's meet in the second